Okay, so 8-2 algebraic vectors. This is changing the pace a little bit from geometric vectors, and now with algebraic vectors we're going to be taking a look at how vectors can be represented using an XY coordinate plane, and how in a lot of cases putting it on an XY coordinate plane actually makes the work a lot easier. To prove this point, take a look at these two vectors, vector r and vector s. We can all agree that they probably do not have the same magnitude. It looks like vector r is just slightly longer than vector s. But can we just tell by looking at it from, say, maybe this perspective here, if it wasn't there anymore, would these two vectors have the same direction? It's tough to tell from a geometric perspective. We'd have to bust out the protractor and go from there. But when we actually have a coordinate plane on here, it makes it pretty easy. Now we can take a look at this here and give this a horizontal length and also give it a vertical length to get from start to finish. So let's mark those in. So as you can see here, this vector s now clearly has a horizontal component, and we can label that horizontal component as having, say, a length of 1, 2, 3, 4 squares. Going perpendicular here, we can take a look at the vertical component here, going 1, 2, 3, 4, 5, 6, 7, 8 squares. Okay, so now we have these two components here. If we transfer that over now, this coordinate plane, over to the other vector, and start to give those some dimensions, maybe like this, and start to give its own horizontal and vertical component, and then we take a good look at this vector, we can see that this vector has a horizontal component of 5 and a vertical component of 2, 4, 6, 8, 9. So now taking a look at these two vectors here with that horizontal component and vertical component placed in here, now we can clearly see that these two vectors are definitely not going in the same direction. Okay, so these two pieces here, the horizontal and the vertical component, become pretty key in giving the vectors that we're going to be working with a little bit of shape and give it a little bit of reference. So what do we do with these horizontal and vertical components? Well, what we can do with those is give them a label in terms of the resultant vector. And definitely you're going to want to note here how we label the vectors in component form. Notice the pointy grouping symbols that we use here for, say, a vector with a horizontal component of 3 and a vertical component of 5. And it's just like an XY coordinate plane. That 3 you see there is definitely indicating the horizontal component, and then this 5 right there is definitely representing the vertical component. So with those two components in there, you look at all these 4 vectors over here, you can see that every single one of them is going to have the exact same horizontal and vertical component. Every single one of these vectors go to the right 3, they go up 5 to get to its destination. Right 3, up 5, right 3, up 5, and right 3, up 5. Every single one of these. Okay? Now, there are occasions where we could have some negatives in there, and that would, of course, indicate if there was a negative here, that means we'd be going to the left. If there was a negative here, that would mean we'd be going down. When it comes to vectors in component form, that becomes very, very important to pay attention to.